Now I've got the head, or excuse me, the cylinder with the studs in place right here. And this is a custom made gasket, copper gasket. It's kind of thick. You can see how thick it is. Let's see if we can zoom in with the real neat and that's looking down the bore of a 120 millimeter stroker. But this is on here really tight, and I can't get it off right now. But anyway, it's got a I'm always getting a little leakage in through this beam, and then sometimes around the studs. And I hope that has stopped. That will stop it. And I'm going to use my. What I'll do is I'll take some of this, and I'll take my Q-tips, which are right here, and we'll shake this up, spray a little bit in the cap, and then when I go to put the gasket on, I will carefully take the Q-tip and go around all these areas with this off, and then I'll slide this on. Now what I did with this gasket is it's made for 52.5 and not a 54 millimeter wide piston. So what I did was I put the 52.5 millimeter on here, and then I took my hone and I honed it out so that it'll cover that very tiny spot that I'm having a problem with. And you can see this. You can see if these studs were in this cylinder without the dowelings, you can see how much slop you can have moving around. And this engine creates so much power that it just vibrates the hell out of everything. So that's where I'm at with that so far. And now the next thing to do is to take the piston over here. This is my new piston. This is an exact copy. This is the old one that almost blew up. But I want to show you something if I get down here. You see the height difference with the new piston compared to the old one? What I have to do is take the one on the left, and I have to grind down the portions on this side and this side in order for it to work with the larger crankshaft weights. Because with the larger weights, when this goes down to bottom dead center, this area hits on the crank weights themselves. So I have to take off. You can see how much meat is taken off right there, and you can see what I started with. That all that probably has got to come off, and a little bit more on this side as it is on this side taken off. And what I do is I take off about as much as I think I need, and not too much. And then what I'll do is I'll come back over here and hook it up to the I forget the name of it. Yeah, it must be getting old. And then I rotate the crank up and down to see if it's going to tap. And usually it hits either right here or right up here. And normally, okay, if I was going to do this professionally as far as building the engine, what they suggest, and it makes perfect sense, is that this is a 52.5 millimeter crankshaft. This is a 54 millimeter piston. What they suggest is that if you have a 50 millimeter crankshaft, use a 50 millimeter piston. If you have a 52, use a 52 millimeter piston. If you have a 54, use a 54. And what they're talking about is weights that are, when the piston is thrown outwards, up and down, is that the kinetic energy is the same as the piston goes up and down as the crank goes round and round, so that it's more in balance. So that way you don't want to put like a little 47 millimeter crank with a 54 millimeter piston. It just throws the weights off. But that's what I can get on that. Now after I get the piston set up,